Today we are going to be looking at Learning Target 7A, Properties of Exponents. First, you need to get your Cornell notes set up with your title, 7A, Properties of Exponents, and labels down the side. Now each slide will have a title and you'll be expected to write everything down. So if you want to save space, you may do that one at a time. The first question we need to answer is, what is an exponent? Well, an exponent is, we write it as b to the x, where b is our base, it's the number we start with, and this number up here where x is our exponent. So make sure you label both of those. Now, over here, we have 2 to the 5th. We say this as 2 raised to the 5th power, and we write it as 2 times 2 times 2 times 2 times 2. Or, if we were to multiply all that out, 2 times 2 is 4, times 2 more is 8, times 2 more is 16, times 2 more is 32. Here on the bottom, we have x to the 3rd. We say that as x raised to the power of 3, or x raised to the 3rd power. And you can see we write it as x times x times x, which can't be simplified, so we still just write it as x to the 3rd. Once we know what an exponent is, we want to look at the product of powers property. Here, we're going to write out x to the 5th, so we're going to write out our 5x's, 2, 3, 4, and our 5th one, and then we're going to write out our 2x's from our x raised to the 2nd power. Now, the product of powers tells us that we can add these up and say that together we have 7 total x's, so it's x to the 7th. If we look down here at our second example, you can see that we have 2a raised to the 3rd times 4a. So first we're going to write that 2, then we know that we need to write 3a's because it has an exponent of 3, and then we know that we need to write our 4a, but a has an exponent of 1, so we just write the a. To combine these, we have to multiply the 2 and the 4, which when we do this, 2 times 4 gives us 8, and then we count up our a's. There's 1, 2, 3, 4 of them, so we write a to the 4th power. When we have a power of a power property, this tells us x squared raised to the 3rd says that we're going to take x squared and write it 3 times, because it says that we need 3 of them. Now, we can know how to expand each of these out, so this is x times x times x times x times x times x. And in the end, we can count them up and write x to the 6th as our solution. Down below here, we have 3a squared b raised to the 4th power. So we're going to write this 3a squared b 4 times. So there's our first one. Here's our second one. Here's our third one. We've got to write one more. So once we write all these out, then we're going to start combining the things that we know we can combine. First, we're going to start with our 3's. We have 1, 2, 3, 4, and they're all being multiplied. So 3 times 3 is 9. We have another 3 times 3, which is 9. Together, 9 times 9 makes our answer of 81. Then let's come up and look at our a's. We have 2, 4, 6, 8, so we have a to the 8th. And then let's look at our b's. We have 1, 2, 3, 4, because they all have an exponent of 1, so we have b to the 4th. So we simply use this to expand it out, and then combine to get 81, a to the 4th, b, a to the 8th, b to the 4th. Now, when we have our quotient property of exponents, here we have x times x times x times x. On the top and on bottom, we have x times x. We will go ahead and cancel any x's that we can on top and bottom. So we see there's 2, leaving us with the solution of x to the 2nd power. On the bottom here, we have to do the same thing. So we have to first expand out the top. So we write 10, and we have to write 4 a's and 1b. And on the bottom, we have to write our 2, 1a, and then we know we're going to have 2 b's. Now we can start canceling things. So we know we can cancel, well, before we cancel, well, we can cancel our a's, and we can cancel our b values here because we have a b on top and a b on bottom. Now when we write our solution, the first thing we have to do is take the 10 divided by 2 and actually do that math. So 10 divided by 2 leaves us with 5. And then on top we have a to the third power left over. And on the bottom we have a b left over. Our negative exponent property is a little bit different than what you are maybe accustomed to. So we're going to spell this out. So we know that 2 to the fourth is 2 times 2 times 2 times 2, which is 16. We know that 2 to the third is 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. And 2 to the first is simply 2. Now, if you look at this, what we can see is happening here is that each time we are dividing by 2. We do it again to get 4, and we do it once more to get 2. Now, if we simply follow this pattern, if we divide by 2 again down here, we know that 2 divided by 2 is going to be 1. So in this case, 2 to the 0 power equals 1. We can follow the same process when we get into negative exponents. So 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. And 1/8 divided by 2 is 1/16. Now, what I hope you notice about this is that 1/2 can be found from writing 1 over 2 to the positive first. So if this goes to the denominator, we get our solution. This is 1 over 2 to the second, because 2 to the second is 4. This is 1 over 2 to the third, because 2 to the third is 8. And this is 1 over 2 to the fourth, because 2 to the fourth is 16. That's an easy way to see how our negative exponent property works. We just move it to the denominator and write it as 1 over the positive version of that exponent. Lastly, we want to talk about the zero exponent property, which says that for any non-zero number a is always equal to 1. Anything to the 0th is always 1. So x squared times y. If we raise all of that to the 0 power, we're going to get 1. If we had, let's see, 532 raised to the 0th power, that would as well be 1. Anything to the 0th power is always 1. We could even make up something crazy, such as 6a squared times b divided by 3a to the 0th power, and all of that will still leave us with just 1. Anything to the 0 power is always, always, always 1. So I want you guys to write this into your notes, that anything, providing it is non-zero, so let's make sure we add that, providing it is non-zero, raised to the 0 power is always 1. We're going to put always 1 in all caps to really emphasize what we're trying to say. Anything non-zero raised to the 0 power is always, always, always 1. I hope that helped, guys. We'll talk about it the next few days.